Good morning, everyone. My name is Jen. I'm a software engineer at Elsevier on the precision medicine team, and today I'm going to talk a little bit about automation and testing. Testing is important no matter what industry you're in, but in the healthcare space, we use it not only to make sure our features work, but we also use it for auditing and compliance and reporting within that. So who here is familiar with Tales from the Crypt? Okay, awesome. For those of you that are not, Tales from the Crypt was a show in the 80s, 90s, and this here is the Crypt Keeper who hosted the show. And every week there would be a new horror story. And the show was actually based on a series of comic books from the 50s and 60s. And I'm going to show you some comic book covers today just to keep this presentation hopefully a little more fun. But I'm going to tell you 3 horror stories about testing and automation. Mostly end-to-end testing. I'm not going to get too much into unit testing or anything today, and how I now avoid that such pain today. So the first story I'm going to talk about is manual testing. And I won't spend a ton of time on this because I think we all know that how tedious this can be. As you can see, this Excel sheet in the back, hundreds of lines of things that I do not want to read or go through manually. But let's take this example of a simple email input. We want to test and make sure this works on our site. Everybody's got something like this on their site. So I asked my QA engineer, what do you have to test if you're doing this manually? And she's like, well, here's a list of things that you want to test to make sure that the email input is valid. And here's a list of things that you want to test to make sure that you can't enter invalid things. So think about the time it takes to manually input all of these different things. And let's step back for a minute and talk a little bit about how teams are traditionally structured with QA. So you might have a couple developers on your team, and then they work on their features, and then you have a QA lead who ends up testing all those features. And sometimes that QA person also works with an offshore team, and there's not really too much interaction between the developers and the rest of the testers. And I never really liked this divide. So what happens with this sort of workflow is that you get stuck in a repetitive workflow, much like this man sinking into quicksand. So the tester tests a feature. If they find something wrong with your email input, they report a defect. Then the QA lead has to then repeat those steps to make sure that the defect is valid. Then the developer has to do that as well to make sure that it's really a defect, and then they can fix it. It goes back to the tester, and then this cycle repeats. So it's pretty annoying. And that's just for an email input. Imagine doing this for a billing field in checkout. It gets scary pretty quick. Luckily, automated testing is not new, and JavaScript has plenty of tools that allow you to do it. These are just a few. I'm not sure why they have this common theme, but it fits this presentation pretty well. One of them I really like, though, that's somewhat new, is called Cypress, and I'm going to do a demo of that for you today. Cypress is different because it comes with everything you need out of the box. Before, you might need to install Selenium and these wrappers and assertion libraries. With Cypress, it's just one command, npm install, and then you can open it. So here's what a simple page load test looks like. We load our site. If we want to do the simplest test possible, we just check that a CSS selector exists, and that's it. So I have a little demo site here made in React. It is just a crypt keeper to-do list. So we all know how this should work. We can add to-dos, we can mark them complete, see what's active, and then we can delete them as well. So let's take a look at what the tests look like for something like this. So this is my Cypress to-do spec. Right here, I think these tests are pretty easy to read and follow without even knowing the Cypress API, if you've never seen this before. But I'm saving out this selector as a named list because I use that throughout my tests. I expect it to have a length of 3 when I start. And then I get the first input checkbox, and I expect that to be checked. So let's take a look at what this looks like when we run Cypress. So Cypress comes with Electron out of the box, but it will also detect Chrome browsers on your machine. So when I open this, you can also see it comes with this example spec, which gives you the entire kitchen sink of the Cypress API. But here is that to-do spec that I wrote. So when I open this, we can see it running all of those tests. And it's pretty fast. It's much faster than anybody could possibly do this manually. And you can also go back and look at each state from each test and see each step as you go along. And that took about 14 seconds. So I really like this tool. If you don't have automated tests yet or end-to-end tests, or if you're looking for something new, I think it's definitely worth trying. So Cypress really makes your testing dead simple. There's nothing to really install or configure, just one thing. And then it gives you really readable error messages. You can also test responsive layouts by changing your viewport size. And it has really great documentation. And I'll post a link to these slides and my GitHub with the example repo at the end of the talk. So having these boring tests automated actually frees up your testers to do what they do best, which is represent your site users and find unexpected functionality or errors. So you want to let the machines handle the boring, repetitive stuff, so everything in this regression circle. Regression testing is the whole gamut, everything on your site, making sure everything works. Sanity testing is testing your features, and smoke tests are like that basic test that I wrote in the beginning that just checks that the page loads. You want to free up your testers from all that regression testing and make sure that's all automated. So that brings us to our next horror story, which is mystery tests. And for this, let's take a look at what a traditional dev workflow might look like. So let's say you develop a feature, then you submit a PR, get it code reviewed. Then once it gets approved, it gets merged into a branch or deployed somewhere. And then it gets tested. And if something is wrong, then the tester has to create a defect and send it back to the developer. I call this the throwing it over the fence workflow, because by the time the defect goes back to the developer, they've already lost context, they've moved on to the next thing. I've seen a lot of times where developers actually don't even know what tests are being run. They don't have any access to the tests, which I think is a big wrong. So what can we do instead? We can take this concept of shift testing left, where instead of waiting to write the tests until after your code is merged, you make sure those tests are included with the code before anything gets merged. This is pretty common with unit tests and TDD, but you can also do this with end-to-end tests, especially if they're written in the same language as your app, which Cypress allows you to do if you're writing a JavaScript app. But hold on. I know a lot of you are thinking, isn't this going to take longer? How are we going to make this work? How are we going to release on schedule? Well, let's take a look at this release diagram, which I got from Microsoft's blog. You have feature 1 and feature 2, which take a long time, probably longer than you expect. Then you get into a little bit of merge hell. And because of that, you end up having some bugs. You need round 1 of QA and fixes. And then you release with some bugs, and then you have round 2. If you just shift that QA period to the left, you end up saving yourself a lot of headache with the merge conflict, and it takes the same amount of time. It just moves it over to the left a little bit. Which brings us to our next horror story, unable to reproduce, AKA it works on my machine. We've all been there, it sounds like. So how does this happen? Sometimes requirements are unclear, or they're incorrect. Sometimes when you're managing many environments and it gets difficult to keep track of what's deployed where. So I've had testers test features and send me defects for things that weren't even in the environment that they were testing. And then we have environment disparity. So different dependencies, different user settings, and then environment-specific changes. A big one here I think that we can all relate to is that we want to deploy static HTML, CSS, and JavaScript, but that's not how we develop it. We use NPM to start a site, and then when we deploy it, we run a build, and then we might use something like Nginx to serve that up. and that's not how we run it on our local machines, so that immediately creates an environment disparity. But we've actually solved some of these issues. If we have our tests written on the same branch as our code before we release, those can effectively become our requirements, so there's no misunderstanding there. And the same thing happens with figuring out which environment your tests are running in. If everything is done before it's merged, then you don't have that problem. But we still have this thing with environment disparity. So to fix that, we're going to dive into containers, and specifically Docker. Docker is small and lightweight. Compared to a virtual machine, which might take up tens of gigs, a container is typically tens of megs or less. It's easily configurable via code, so you can see what's going on, and it's open source. So let's go back to our demo. First, I'm going to stop the site that we had running. And we're going to look at how we can run this demo site in Docker. So we're going to use Docker Compose to do this. Docker Compose lets you coordinate different containers and services. But even though we only have one service listed here, I find it more convenient to list out my parameters and configuration here rather than pass a bunch of command line flags. So let's walk through this file and see what everything means. Version 3 here at the top is the version of Docker that we're using and expecting. And then we have a list of services. We only have one service here. I'm calling it our UI. And we're telling it to use the Node 8 image. So that pulls from the public Docker repository and grabs Node version 8. If I wanted to say, try this out in Node, a newer version that comes out, all I have to do is update this number and test it out on my machine. Then we have some port mappings. So on the left is the port that I want to access it on my machine. On the right is the port that's going to be running on in the container. And typically you just use the same port, but just for demonstration purposes, I have this mapped to a different port, 3333. So instead of accessing localhost 3000 like we did before, I'm going to access localhost 3333. And I also have a mock API running in the background on port 3001, so I'm also mapping that here. And then we're going to mount a volume. So here, what we're doing is saying, take everything in the current folder and mount it to this folder called app in my container. So everything here on the left side of the screen will be mapped into that folder in the container. And then we're going to run a couple of commands when the container starts. We're going to cd into that app directory that we mounted everything into. And then we should have access to all these files on the left. We are not going to run npm install on the conference Wi-Fi because I already have everything installed. But you would want to do that. And then npm start. So to do this, all we have to do is run docker compose up. And that, by default, looks for a docker compose.yaml file. You can specify other files as well. But what is happening here is that it's running npm start. So we see that our JSON server is started in the background. Now it's starting the dev server. It's going to tell us that that's on port 3000. But we know that I mapped that to port 3333. So now we should be able to access the site. So just to prove this doesn't work, 3000 won't load anymore. But now I can access the site at port 3333. And this should still function all as expected. There we go. So that lets us run our local site in Docker. But what about that environment disparity when we want to deploy something to production and we want to test our code that's actually built? So for that, let's take a look at a different Docker Compose file that will use Nginx and our compiled code. So here we have two services. One of them is called Nginx, and that's going to pull the latest Nginx image. And then we're going to mount our build folder into where Nginx expects our HTML to be. And then we're going to mount our Nginx configuration file where that expects to be as well. So if you've ever had to test an Nginx config file on your local machine, it can be a nightmare, but this makes it so much easier. So this is just a typical Nginx configuration. We're redirecting everything to index for our single page app. And then we have our UI container. So say that a new person starts on your team, they have a brand new machine, nothing is installed, they don't have Node. If they just install Docker, they can run this without having to install anything else. But remember that we want to serve the compiled files, so we need some way to compile them. So we create this UI container, which will just do npm run build for us. And for that, we create a custom Docker file to work with some caching to make this more efficient for us. So let's take a look at that. So this is all it is. It's saying that we want to use Node 8. But this time, we're going to install all our modules in the container itself and cache them one level above our app, just to make this faster every time we run it. And then we set our working directory to that app folder, just so that any commands will automatically run from that. And I am also symlinking the parent node modules into the node modules in my app directory, only because of the way that React scripts needs to build some things. Hopefully, we don't need to do that forever. But you might not need to do this in your app. But if you haven't ejected your build scripts, you might need to do this. So let's take a look at what that looks like. So to specify a different Docker Compose file, you just use the F flag. And then you can specify the file name. And then you just run Docker Compose up with that file. It will create the build for us. And then since I've already run this, it's already built those images. The first time you run this on your machine, it would have to build those images, run npm install, and all of that. But since I've done it before, it will use the cached versions. So now our site is built. And I believe I mapped that to port 4000. So you'll see this doesn't run anymore, but port 4000, we can access our site. And we're not running our mock database or JSON server database here, so that's why we have no to-dos. But this still works as expected. We can mark things active, complete, and so forth. So this gives you a good way to test your production site on your local machine. But there's one more case that we need to cover, and that is running our tests. We want to be able to run our tests and then exactly reproduce our test output anywhere else. So how do we do that? Let's take a look at one more Docker file, the last one. So here we have two services, one called Nginx and one called test. So Nginx is basically the same as the one I just showed last time, except we're setting up a network and assigning an IP address so that our other container can talk to it internally. So our test container has another custom Docker file. Let's take a look at that. And this one is very similar to the last one, except we're taking our base image from Cypress. So Cypress actually provides you a base image which comes with everything you need, such as like XVFB to run your headless tests. It does not come with Cypress installed, though. So what we're doing is the same thing about caching node modules. We're copying our package.json and our package lock.json, running npm install. And then just to save some extra time, Cypress also runs an install and verify step. So to save some time, we're going to cache that in our Docker file. And we're also downgrading npm just due to an issue with that. So in our test file, we're also going to tell it that this container depends on Nginx. So we can't run any of the tests until Nginx is serving our content. So we tell it that don't do anything until the Nginx container starts. You want to be careful with this, though, because it will wait for that container to start. It will not wait for all of your commands to run. It just says, does that container exist and is it started? We're also going to tell it to link to that container, set some environment variables. CI true is just a typical one that's set. We're going to tell Cypress that our base URL is the IP address of that other container. And then we're going to set video recording to false. Cypress will record videos for you so you can see the test output by default. But since we're not saving them anywhere, we don't need them. So I set that to false. And then we're mounting our app folder. So what we do here is run the build, and then we tell Cypress to run. So let's see what that looks like. So I also, I think, set logging to false because I only want to see the output, or I set logging to false for the Nginx container because I only want to see the output from the tests. I don't want to see all of this stuff that Nginx outputs every time someone accesses a page. So our site is built now, and our tests should start shortly. And this will also let us see the difference between running with and without video recording. And it didn't really actually save us that much time. But we can see that the tests exited with code 0, so that means everything's good. And we can close that. And there's also a command to automatically exit with the exit code from a particular service. I have all of that listed in the README in this repo so that you can get that output on your CI server. So let's recap a little bit of what we talked about. We talked about updating your tooling with Cypress or any sort of automated test. As long as you're writing some tests somewhere, it's better than nothing. We talked about updating your workflow to shift your testing left and keep testing closer to development, and then updating your infrastructure to make things reproducible. But more importantly, you need to see eye to eye with your team. So just make sure you're writing some automated tests. Hopefully your developers write some, your QA team writes some. They work together. Make sure they're available to everybody so that you know what's being tested everywhere. And try to keep your testing as close to development as possible. Use Docker for some environment parity, and then really adjust for your team. This isn't a change that I made with my team overnight. This took many months to sort of get us into a good workflow. So hopefully some of the things I shared are useful to you today. Thank you very much. You can find all of the examples that I showed at this URL.